Hi everyone, welcome back to my series on my senior project, a personal pick and place machine. Now, before I get into today's video and topics, I'd like to remind everybody that I am on a team. I'm on a team with one other electrical engineer, two mechanical engineers, and one engineering technology major. Now, the topic of today's video is going to be the electrical schematic for our machine. It is currently on version 2, but I'm sure there will be a couple more renditions to come. But the current one is quite solid, and I don't see too many more changes in the future. So let's go ahead and open this up. So if you'll remember from the past video, uh, I went over all the parts and their functions. You would do well to remember some of these, mainly the Nano and the Tiny G, maybe even the Raspberry Pi high quality camera here. But some of these I did not display or I did not talk about too much, so that's what we will talk about in this video. Let's first begin with just going over the Tiny G, or sorry, the just the Nano and its connections. So obviously the Nano is responsible for running all of our software, as well as our pre-trained AI. This AI is going to make decisions based on the feedback from the Raspberry Pi camera that is connected through this um, CSI port here. Now, the Nano will be connected to a display via HDMI, and this display will have all the user interfaces like OpenPNP and OpenCV, where the user can drop files and activate and deactivate the machine. Now, coming over here to the Nano and Tiny G, they are connected via USB, USB-A to USB-B specifically. Now this enables UART serial communication. I would love to do a video on this as I had a blast making them communicate and watching sort of the first steps and all that with the G code and all that good stuff. So I'd maybe expect a video like that soon. So the Tiny G is connected to those stepper motors through the respective motor drivers, and they drive the axes X, Y, Z, and C. Now, the Tiny G's firmware actually refers to its rotational axis as A rather than C. C is actually used in OpenPNP. So whenever you go to set up OpenPNP with the Tiny G, you actually have to um, switch out the rotational axis and make your own make your own rotational axis there. So connected to the Tiny G is this driver fan. This driver fan is a 12-volt driver fan, but it can be between 12 to your voltage supply here, depending on what switch you choose on the Tiny G. I just chose a 12 volt just for simplicity, I suppose. The driver fan will cool the Tiny G and the Jetson Nano. Now, if we move into here, we will see all of our interface pins. If you recall from the past video, I talked about some of our actuator scripting. These are our data lines from those scripts, and they come down to follow this yellow and green one here down to our actuators, specifically our feeder actuator assembly. You will see that this assembly communicates with the Nano through I2C. We have SDA in yellow and SCL in green. We have a supply voltage of 3.3 and a motor supply voltage of 5 volts. Now this board is the PCA 9685, and this is an incredible board for a project like this. I'll just note quickly that we only have 2 servo motors currently, just as a proof of concept for the prototype that our AI can distinguish between 2 different components. But ideally in the future, we can use up all of these channels for different components. So Let's come back up to our interfaces. We will follow this purple line here. Now this purple line leads into our TB6612 motor driver. Now this motor driver drives our 12-volt vacuum pump over here. I could have just simply used a relay, but I actually have one of these just on hand and figured I could save our team some money just by using that instead. So we have our motor supply voltage here of 12 volts, our board supply voltage of 5 volts, and then I just stuck our pulse width modulation channels to high just to enable them. And then I have our analog input 1 set to high, and then our analog input 2 set to ground. This just sets the direction of the motor. Now, what the great thing about this is if I do want to actually change the speed of the pump, say it's too loud, I can actually take this pulse width modulation channel and plug it into one of the channels here on the PCA 9685. Let's see, I do believe we have one more connection left. Follow this pink line here, come down, and we will arrive at our camera LED. The camera LED just lights up our workspace. If you remember from the first video, it's part of our precision systems. It just lights up our workspace and ensures that the Raspberry Pi camera is getting quality footage for our AI to make decisions on. Now I know there should be a resistor here right after the LED or even before, just to limit the current to it and keep it from burning out, but I believe I ran out of space or just maybe forgot, but important to note that that should be there. All right, I do believe that covers everything. If you guys have any questions or concerns, I would love to hear about them. Like I said, I'm open to some more renditions of this circuit for sure. But as far as our plans right now, I am fully ready to follow this circuit. Thank you guys for watching.